In this video, we're going to talk about 1.2 Objective 3, where we graph and write formulas for piecewise functions. Piecewise functions are going to be important for us to know how to deal with here in calculus. So let's go ahead and write a definition of the piecewise linear function y equals f of x that is given in the graph over here to the right. So we're going to have to find the slope and a point for each piece to maybe the y-intercept if we know it for that piece. So let's go ahead and look at the first one. Definitely looks like we have the point -2, 2 for both pieces. So we can use that, -2, 2. And then it looks like we have -3, 0. So our slope looks like we're going right 1 up 2, which is a slope of 2. So 2 times x minus a -2 is x plus 2. And this is y minus 2. Y minus y1 is equal to m times x minus x1. Y minus 2 is equal to 2x plus 4. Y equals 2x plus 6. For that first piece, when we're less than or equal, or when we're less than -2, then greater than or equal to -2. Keep this same point right here. The slope appears to be, it looks like we're going through 2, 3, 4, 0. Appears to be on the line there. So we went right 6 and down 2. So slope is down 2, right 6 is a -1/3. I guess there's a point somewhere over here that I could have used, but -1/3 for my slope. Y minus 2 equals -1/3 times x plus 2 using that point again. Y minus 2 equals -1/3 x minus 2/3. Add 2 to both sides. We're going to be adding 6/3 as y equals -1/3 x plus 4/3. And there we go. This next one here, we have two pieces for the graph. So that's b, and it's a constant function. When we're less than 2, we are at y equals 3. And then for the next piece, we're going up 2, right 1. We have a slope of 2, and we have the point 2, 3. So that's y minus 3 equals 2 times x minus 2. Y minus 3 equals 2x minus 4. Y equals 2x minus 1. When x is greater than or equal to 2. Okay, this one is not continuous. I have to pick up my pencil to draw it. So we have a piece with a positive slope that's going to stop at x equals 1, 2, 3, 4, looks like. So that first piece is less than, or is less than 4. So we're dealing with one of these, and then this piece is greater than or equal to 4. It's going to have a slope of -1, right 4. So that looks like C. Okay, this one, if we factor, this is the same thing as x as long as x is not equal to 3. So we're looking for y equals x with a hole at 3, 3. and that looks like B with the hole having a point over top of it at 3, 7. Similar thing here. For x not equal to 1, we have x plus 1, x minus 1 over x minus 1. So this is going to be x cannot be 1, and it's going to look like x plus 1. There's going to be a hole at 1, 2. Hole at 1, 2. And that hole is has a point above it at 1, 6. That looks like A. All right. When x is less than or equal to 0, have a slope of 3. They're not going to connect to each other. So less than or equal to on the left is going to be one of these two, and it has positive slope, so it's got to be B. All right. Next one is number 7. And we have negative slope to the left, positive slope to the right. To the left, it's less than or equal to. And to the right, it's strictly greater than. So positive slope to the right has to be B. All right, now this one is in 3 pieces. So let's look at these 2 pieces are easier. Between -1 and 5, not included, we have a y value of 4, and it's going to be it's going to have a jump over here on the right. So that's got to be A or C. For greater than or equal to 5, it's going to be on the line y equals x, which has a positive slope. That means that it has to be C. Now we've got another 3 pieces here, positive slope, a little bit less positive slope, and then a negative slope. And this is open, and it hits 2, but then that 2 is closed up. The next place, 0, 2, and then goes out to 2, 4. And then we have 2 minus 1 is 1, looking like B to me. All right. Now we have a linear piece and then a radical piece. And this goes from 2, 3 to 5, 8 to 27, 8. This goes from 0, 0 to 2, 3. And then this one goes from 27, 8 to 35. That's 8, that's 64. So that's 35, 0. All right. So 0, 0 to 2, 3. Nothing should be missing here because all the holes are plugged up. Can't be this one, can't be this one, can't be that one because there's no holes in the graph. So it's got to be B. The reason it can't be this one is it can't be down here left of 0, since we start at 0 here. All right, graph the square wave function as defined. We're oscillating between 0 and 1, and then 0 and 1, 0 and 1. That's B. And it's closed on the left, open on the right every time. That's why it's B and not C. All right, sketch the graph here. Y-intercept of 5, slope of -3. So looking like could be B here. Yep, it's B. So I just stuck in some points and tried them. This has a y-intercept of 5, a slope of -3. Then this piece has its vertex at 3, 1 over here, but it's open. And greater than 3, we're going to have the right half of the parabola there, right 1 up 1, right 2 up 4, and so on. So it's B. All right, this one has a little extra zing to it. It's one of the extra problems. So between 0 and 3, we have f of t equals t, which is going to go up and to the right. And then 6 minus t, that's going to go down and to the right. So I have to have both pieces, so up and to the right and then down and to the right. That's C. Then we want to find area. Let's go ahead and find these area functions first, even though we're asked for them later. It'll help us to plug these numbers in. So if I have anything less than halfway over, we're going to form a right triangle when we make the area. Our x value and our y value will be the same with the function y equals x, essentially. So we're going to have 1/2 xy, which since x is the same thing as y, we're going to have 1/2 x times x is 1/2 x squared. And that's for anything that is less than or equal to 3, between 0 and 3. Now, between 3 and 6, I'm going to have to think of the whole thing here was, so 3 squared would be 9, 9 halves plus another 9 halves would be 9. So start with 9, and I need to subtract the open, the part that's not shaded over here on the right, which is a right triangle, which is going to be 6 minus the x value squared times 1/2. So this distance here, 6 minus 1/2, it's also going to be the height this way. So for instance, when x is going to be 5, 6 minus 5 is 1. It's also going to have a height of 1. That is going to give me an area of 1/2 that I'm going to subtract from the 9. 9 minus 1/2 is going to be 18 halves. Minus 1/2 is going to be 17 halves. When I have x or t is 1 here, plug it in here, 1/2 of 1 squared is 1/2. So half, 17 halves. Yeah. And I'm just going to put this in as 9 minus 1/2 of 6 minus x squared. You can simplify that if you want to. Let's go ahead and do that. 36 minus 12x plus x squared is 9 minus 18 plus 6x minus 1/2 x squared. This is a negative 9 plus 6x minus 1/2 x squared. So that's how they had written this. It's the same thing. Negative 1/2 x squared plus 6x minus 9 for my function. Got one more problem here, and that's to write this as a piecewise defined function. Remember that the absolute value of x is equal to x. If x is greater than or equal to 0, the absolute value of x is equal to a negative x if x is less than 0. So I can write that as a piecewise defined function like this, and I'm just going to make those substitutions here. So if x is greater than or equal to 0, x minus x is 0, 5 times 0 is 0, 0 plus 1 is 1. X minus a negative x is going to be a positive 2x. 5 times 2x is 10x plus 1. And then that's if it's less than 0 there. And so this is going to go, it's going to equal 1 to the right of 0. So that's not this one. And that's not this one. And that's not this one. That's this one. All right. That's it for this video. And we'll come back next time and we'll talk about 1.2 Objective 4. See you for the next video.